My dear friends, my dear students, today we will discuss the concepts related to fourth module. That is about the queues. Queue means here queue is nothing but it is a type of data structure which will work on the principle of FIFO, that is first in for first out. Here Q, this is for example, this is a Q which is having this is the Q which is having the elements. The first element here, this is here it is having two ends, front end and rear end. Data will be inserted from the rear end and it will be deleted from the front end. That is, it is a data structure where we'll insert the data, where we are having the datas which will work on the principle of FIFO. FIFO means first in first out. Which data which we entered first, that we can delete first. Whereas in stack, the it will work on the principle of LIFO, means last in first out. Last in first out means suppose we inserted some data 50 last, but will take that data first, afterwards only we can take the next data. But it is not like this. It will in queue, which data we entered first, that will come first. For example, the analogy for queue is suppose example is that bus is having two doors, and from back door the people will enter the bus. From front door people will leave the bus. This is the same type. It is also a queue in which we'll insert the data, and from rear end, but the data will be retrieved or taken outside or accessed from the front end. This is about the queue. Simple. It will work on the principle of FIFO. The various operations that we can perform on the queue are, will perform, that is queue overflow, insertion of the element in the queue underflow, deletion of the queue, display of the queue. So many operations we can perform on the queue. That is here. Suppose we want to insert the data into the queue. How we can insert the data into the queue? Suppose we want to delete the elements from the queue. How we can delete the elements from the queue? Suppose we want to display some elements which are there in the queue. How we can display those elements? With a program, we'll come to know how we can perform various operations on the queue. That is how we can insert the data into the queue, how we can retrieve the data from the queue, or how we can delete the data from the queue, or how we can display the content of the queue. Like this, with a program, we'll discuss all these concepts one by one. First, we'll discuss about the program for implementing the queue using array. This is using array, how we can analyze the queue, the array representation of the queue. Here, with an example, we'll discuss all these concepts. For example, program for implementing the queue using arrays. That time here we are having so many. First, we have to declare so many data types. Sorry, we have to we have to we have to we have to mention so many header files. That is hash include iostream.h, hash include iostream.h. We have to mention so many header files. We have to mention so many header files. That is hash include iostream.h, hash include stdlib.h, hash include conio.h. These header files we have to include. We know that why we have to add these header files. Then we have to, at the same time we have to define hash define size file. Means here size of the queue is 5. Means at the most we can add 5 elements in the queue. Then we'll have the class is my queue. Here we have taken a class name is my queue. class myQ. Class is having the private members, class is having the public members. Here in the private member will declare about the q, that is struct q, int q size. Here we'll mention what is size, either it is 5, 10, 15, what is size. Then int front rate, here we'll take two variables int front, these are of types int. Then we will declare some function members in the public. In that we will declare some functions. Those are nothing but myQ, int qfull, insert, qempty, delete, display. These are the functions which are there in the class myQ. Here, therefore, after this white display, we flower bracket, closing flower bracket, semicolon, means it is end of the class. Then after here we have declared so many classes, so many functions, myQ, qfull, insert, qempty, delete. We have declared so many functions. Now we'll define those functions one by one. That is myQ is myQ scope resolution after myQ, then qfront equal to -1, qrear equal to -1. That first we will initialize the qfront as -1, qrear as -1. This means this is a queue where we can store the data. Since size of the queue is 5, therefore we are having 5 memory locations, 1, 2, 3, 4, 5. Then now qfront and qrear equal to -1. When both are pointing to -1, means this queue is empty. Here, that is queue is empty. Therefore, in the beginning we will treat qfront equal to -1, qrear equal to -1. Then we will define one more function, that is what, qfull. When q is full, what it has to display, how it will come to know q is full. If qrear is greater than or equal to size -1, size -1 means what is the size? 5. 5 minus 1 means it is 4. If here is, you see here, if size is 4, this is 1 1. When we insert the data here, 1 2 3 4 5, when we insert the data, similarly the rear, this pointer will point to this like this, it will come to here. First, when it is here at this point here, no space, no memory location is there for to insert the data. At that time, if this pointer rear comes here, means it is pointing to 4. If it is pointing to 4, qrear is 4 or greater than 4. 4 is equal to 4. Yes. Why? Because size is, maximum size of the q is 5. 5 minus 1 is 4. 4 is equal to 4. Yes. Therefore, return 1. Return 1 means that is q is full. Therefore, if q exceeds the maximum size of the array, it returns 1. Means q is full is true. Otherwise, 0 means q full is false. If this is q is not full, or when qrear is not greater than or equal to size -1, then q is not full. When it is full, when it is equal to 4 or greater than 4, then it will tell that is q is full. We have defined this. We have defined the q full function. Next, similarly, we will define the other functions also. That is int myQ, insert item. Suppose we want to insert the item. How we can insert the item? What is the condition? What happens if q equal to qfront? If qfront equal to -1, means when q equal to qfront equal to -1 means what? When the qfront is -1, it means it means that the q is empty. Therefore, q is empty. Q is empty. We have to increment. Of course, we can insert the data, but we have to increment qfront so that it will point to this location. -1, when it is incremented, it will become 0. Qfront will become 0. This is only first. This condition will occur initially when q is empty. Only one time we have to increment qfront. Afterwards, when we insert more data, at that time will not increment qfront, will increment only the QRare, because QRare will point where we have to insert the data, to which location. Therefore, here this. Therefore, always increment the rear pointer and place the element in the queue. Here we have to increment the rear, and in that location we have to add the data. Therefore, return rear. How this is how we have defined the insert function. Next, similarly we'll define the empty queue empty. If suppose queue is empty, what message, how will we come to know what is the message will display? When will come to know the queue is empty? If queue front is equal to -1 or queue front is greater than queue rear, then it means queue is empty. Queue front is equal to -1 means queue front is equal to -1 means queue front is equal to -1 means definitely the queue is empty. One more condition is that when now it is queue front is how when we are enter the data in here, we enter the data, and the rear is rear is pointing to the last memory location. Suppose we will delete the data one by one. When we delete the data, the front is point to this. When it is pointing to this, we can delete this data. After this, front is incremented. Now we can delete the data. Suppose we all delete like this. If the front is exceeds the rear, if this when front is equal to rear, it can delete this data. After that, it is incremented. When it is incremented here, at that time what happens? Already it has deleted all the items which are there in the queue. At the time when front exceeds the rear, means the queue is empty. When either this or this condition satisfied, queue front is greater than rear, means it has deleted all the elements which are there in the queue, then queue will be empty. Then only it will display the message, or it will tell that the queue is empty. Return 1 means the condition is correct. Otherwise, else means the return 0 means the condition is false. It means false means the queue is not empty. Like this, will display so many will define so many functions. Similarly, we will define one more function, that is int myQDelete. Int myQDelete. Here, first suppose we want to delete some item which is there in the queue. At that time, int item equal to queue front. Item equal to queue front means first it will the elements will be deleted where queue front is pointing. Therefore, suppose 5 elements are there in the queue. Queue front is pointing to this, queue rear is pointing to this. At that time, suppose the element deleted, we can't delete any element, only where the queue front is pointing, that element only we can delete. Therefore, now queue front is pointing to this. Therefore, item equal to queue front. Queue front, this means this is the item, this will be the item 10. Therefore, queue front plus means after this queue front should point to this location. This is the item. This beginning item and queue front is pointing to this location, but we have incremented the queue front, means now it will point to this location, and we'll delete this. Now we can delete this data, means queue front always points the location where the queue starts. Therefore, when queue front, then the delete item display the deleted item is item is what? Item equal to queue front. This is the item, this will be the item. Therefore, it will delete 10, but after this it will not point to this location. Queue front is not pointing to this location. To which location is pointing? Is pointing to this location. Why? Because already we deleted this. Therefore, we have to increment queue front plus means we incremented queue plus. Like here we have defined so many functions. Then one more function, that is we have to define, that is display. Suppose we want to display the content which is there in the queue. At that time we can display those elements which are there in the queue. For example, for I is equal to q friend, I less than equal to q rare, I plus plus. Suppose here, for example, here q front is pointing to this, q rear is pointing to this. Suppose we want to display these messages at that time, I equal to q front, this I means it is pointing to this location. If it is less than this, as definitely it will less than this, will it will display this. Afterwards, what we'll do, will increment I plus plus. Now I plus plus point to this location and it will display. Is it less than this? Yes, then it will point to this. Is it less than this? Okay, like this, using for loop, we'll check I q front, I is less than equal to q rear. Yes, then I plus plus increment then and display the elements one by one. Using this will display. Since this loop, it will continue executing this loop up to what, up to when this condition fails. When what condition? Q I is less than q rare. Q rare, initially I is what is the value of I value is this q front. After every iteration, every loop, the I is incremented. When I plus plus is pointing to this location, means it is greater than, it is not, it is I is incremented. If I is less than or equal to qrr, it will execute. If I is more than, I value is more than this q rare, at that time the condition fails. When condition fails, come out of the loop. Up to what, until that, what happens, it will execute all the contents which are there in the queue. It will display all the contents. This is the one more function we have defined here. After that, the main program starts. Here main program, what is the main program? Here void main, void, here the program's main program starts. Here we have taken the main program as void. Some other programs we have taken as int main. When we return int main, we have to write the return instruction. Since we are here, we have taken void main, therefore no need to write return instruction. Then we'll here will define some variable, we'll declare some variable, choice item. These are the choice item are the variables of type int. Here we have to mention, if we have taken the choice, if taken the variable item, what type of it is. Therefore we will take these are the int. But here we have taken one more variable, answer. Is it of type what type of it is? It is like character. Character means only single character. We have to mention either s, y, n. Like if it is for yes, suppose I want to tell yes, we have to write only y. Suppose we want to tell no, only we have to write n. To write only single character, we will take a variable answer. It is of type char. Then myQobj. Here for class, in all the classes we have done like this one. For a class we have created object obj. In all classes we have done like this. Using this, okay, when we have created this object, taking this object, we can call the functions. Therefore for class myQ, we have created an object by name obj. Then clear screen. Then do this is do, we have taken do while loop, so that it will repeat the loop until the condition fails. Therefore cout main menu. Here cout main, it will, first when we execute the program, it will display main menu. Then it will display one is insert, second one is delete, third one is display. Then it will display enter your choice. Like here you see that after execution, it will display main menu. One is insert, second one is delete, third one is display, enter your choice. Like this, it will, for display purpose, we return this instruction. Then switch one, choice. Suppose our choice is 1, then when choice is 1, it will come to case 1. Case 1, choice is 1 is what? Choice 1 is insert. Suppose we want to insert the data into the queue, at that time it will come to case 1, and the instructions whatever there here, it will execute those instructions. Here when if suppose your choice is 1, it will come to case 1. If obj q full, if the q is full, the queue is full, then there is no option to insert the data into the queue, because or choice one is what, insert the data. If already all the elements are there in the queue, then where is the space to add few more elements at that time? Therefore, at the beginning only it will check whether queue is full or not. If it is full, no problem, no option, we can't add the data. For that, it will check whether it is full or empty. For that, it will check if obj queue full. If it is full, then it will display the message cannot insert the element, cannot insert the element. Or else if it is not full, then it will not execute, it will not display this message, or instead it will go to else, and it will display the enter the number to be inserted. Then it will display this message, and suppose you enter the message, enter the message, sorry, enter the data, enter the element, it will take that element. After that, it will come here, obj insert item. Obj, when this instruction is executed, this instruction is nothing but, when this is it will go to, it is a call instruction, it will call the function, that is insert. Already we have defined so many functions, that is insert function, display function, and that is delete function, item full, queue full function, queue empty functions. Therefore, when this is executed, this will go to that function. What is the function? Insert function. Already we have defined all the functions. It will come here, it will come here. Where is the insert function? It will come here. Here insert is there, it will come to here, and it will execute these instructions whatever there in the instruct function. In insert function, if first it will execute, if q front is equal to -1, suppose q is empty, at that time the value of q front will be -1. Already we have discussed that one. If q front equal to -1, q rear equal to -1, means if it is point q front and q rear pointing this the q is empty, therefore it is empty. Then we have to increment q front. Then this incremented only one time, because always after incrementing, this condition will occur initially when q is empty, only one time. If already some item is there, at the time it will not execute this instruction. Q front is not equal to -1. Suppose some data is there, at the time it will not increment this, instead it will increment q rear. Always in the program, the q rear will incremented when we add that. Here they have given, you see here, increment q rear. Always can increment the rear pointer and place the element in the queue. Important. Q front will not be incremented, only q rear is incremented when insert the data into the queue. Q front is incremented when it is incremented when we delete the data from the queue. Important. Therefore it will insert the data, and after inserting the data, then here break means switch statement, come out of the switch statement and execute the next instruction. What is, do you want to continue? Here you see, enter with choice 1. Afterwards it will ask enter the number to be inserted 10. Here after that it will ask, do you want to continue? If you write yes here, yes, answer is yes, then it will check yes is equal to yes, the condition is true, yeah, yes is equal to yes. Therefore once again it will repeat the loop, and will come here, and it will once again execute all these instructions. Menu, insert, one is insert, second one is delete, third one is display, then enter your choice, then see in choice. So here we want to enter the choice. Suppose you write choices your 2 10 using the switch statement. Here switch choices 2, at the time it will not execute case 1, it will execute case 2. Case 2 what? Here case 2 is what? Case 2 what? To delete the element. Here insert, second one is delete the element. Suppose we want to delete the element, at that time it will come to case 2, and here it will execute this instruction. First it will check obj qempty. If something is there, some element is there in the queue, then only it will delete. If no element is there in the queue, how it can delete? Therefore, it's no element in the queue. At the time, it will display the message queue underflow or queue is empty, or okay, like that, then it will come out of the loop and execute this instruction. Do you want to continue? Otherwise, some data is there, at the time it will not execute this, else it will execute this instruction. It is obj dot delete. This is nothing but calling the function. Which function? Delete function. When this is executed, this function is called. Which function? Delete function is called, and the cursor will go to delete function. Where is the delete? Delete is here. Delete is here. Int item equal to, here these are the instructions, sorry, datas which are there in the queue, 10 20 30 40. First, what we do, item equal to queue front. Queue front always point to this location, and will treat this will be the item means this we want to delete, and after we will select this, and after this we will increment queue front, because it has, after deleting this, the queue front should point to this location, not this location. Always queue front points where the data, which data we want to delete. Therefore, we have to increment queue front, and the deleted item is item is what? Here, this is the item, this is the element which is there in this location. This will be the item. It is delete this item. After this, it will delete. I already told that queue front end will point to location where we will delete the data, and rear point where we have to insert the data. Important. Here, this is we are having, it will delete it. After this, in the queue, where we'll have only this 20 30 40 50. These are the elements will be there in the queue, because this will be deleted. Now queue front is pointing to this location. This is how we can delete the item from the queue, like this. When we execute this instruction, delete. After, next instruction is break. Break means comes out of the switch statement. Here come of the switch statement. Then, do you want to continue? If your answer is yes, get the value. It will take the value as y, and it will check while y equal to y. Yes. S means once condition is true, then once again it will come here. It will come to and repeat the loop. And once again it will display main menu, insert, delete, display. You enter your choice. Suppose you enter your choice as a 3. Another time, when you enter the choice 3, it will execute. Now it will go to the case 3, not 1 or 2. Case 1 is there, case 2 is there, case 3. You suppose your choice is 3, it will come to 3. Therefore, when it come to 3, and it will first it will check queue empty. Suppose it has to display. What is your choice 3? Choice 3 is display this. Therefore, displaying, before that it will check that is queue. Either some element is there in the queue, then only it will display. If queue is empty, how it will display the elements which are there in the queue? Therefore, before that, case 3, it will check that is either queue is empty or not. If obj queue empty, if it is empty, queue is empty, it will display the message queue empty and comes out of the loop. Or if some data is there, at the time it will not execute this, else it will execute this instruction obj.display. This instruction is nothing but the call instruction which will call the function display function. Where is the display? Display is here. Display here. It will come to this instruction and execute this. Int I q front I rear, I less than equal to q rear I plus plus. This already we discussed about how this function will work, how display function will work, how it will display the content of the queue. Then after displaying, once again it will come back here. Come back, break means comes out of the switch loop and execute. Do you want to continue? Do you want to continue? Once again your answer is yes. Gets h. Yes. Gets h. Yes, why, then once again it will come here. Once again it will come here, switch, it will come to here, it will display all this main menu, everything it will display. Switch, choice, suppose other than 3, suppose your choice is 4 5. At that time, if choice is other than 1 or 2 3, if you entered choices 4 5, at that time it will execute the default instruction. Default, wrong choice, it will display this. Then break means comes out of switch statement. Once again it will display this. Do you want to continue? Suppose this time your answer is no. Your answer is no. N is equal to, answer is no. No means n. At that time, why n is equal to y? N is equal to y? No, n is not equal to y. Therefore, the condition is not satisfied or the condition fails. Therefore, it will not repeat the loop. So far it has repeated the loop. Why? Because the condition is true, y equal to y. But when you enter answer as n, then n is not equal to y. Therefore the condition is failed. Therefore now it will not repeat the loop and comes out of the loop, and this is the end of the program. This how, using the queue, how we can execute the program, how we can insert the data into the queue, how we can delete the data from the queue, how we can display the content of the queue. This is one example. There is about how we can perform various operations on the queue. Important. Such questions will be asked in exam. Program for implementing the queue using arrays. In the exam, sometimes they will ask you write a program for implementing the queue using arrays. At that time, you have to write all this program. All this program you have to write. At the time, suppose you ask such questions, they will ask for 20 marks. 20 marks, because the program is so lengthy, therefore they will ask for 20 marks. Here in C, data structure using C++, in every question you have to write the program. For example, explain with an example the function overloading. Explain with an example the operator overloading. Explain with an example class with an example. Whatever you take, everywhere you have to write the programs. Sometimes explain with example. Example means also you should understand that you have to write the program. Need not to compulsory they have to write with a program. You have to explain, like not like that. Example means you have to write the program. In every concept you have to write the program. For example, explain the example. The function overloading means small, with small brief you have to write about the function overloading. Then with an example means once again you have to write the program only. Everywhere program. Therefore you should be perfect in program. In all cases you have to write the program only. In C++ also, in the data structures also, you should be perfect in programming. Okay, this is about the queues. In the next class we'll discuss a few more concepts related to queues. Okay. Okay, thank you.